This presentation focuses on the negative effects of invasive Chinese wisteria on local flora and the steps that landscapers and landowners can take to mitigate the destruction of native species. Not all species introduced to an environment become invasive. Invasive species are those which adapt to new environments by responding well to the selective pressures placed on them by high genetic diversity and the negative frequency-dependent selection. Over 50% of invasive species are introduced for ornamental purposes. This is the reason that Chinese wisteria was transported to England and the United States. Invasive species persist through hybridization with local flora.
Wisteria sinensis first arrived in England in 1816, brought from China by Robert Wellbank and planted at the home of Charles Hampton Turner. From there, the plant not only spread naturally through hybridization and reproduction, but it was also transplanted and traded through English and American trading routes. The plant was found charming for its vast number of beautiful purple flowers and was therefore sought out by artists and landowners as well as botanists and nurseries.
Wisteria sinensis, commonly known as Chinese wisteria, is a woody vine plant that's most easily recognized by its lavender inflorescences. It can be commonly seen in Athens even during the springtime. Although it's a vine, many people can confuse it as a species of tree. This is when the aggressive and dangerous side of Chinese wisteria is revealed. While Chinese wisteria is beautiful, its problem lies in its growth habits. Wisteria will grow up pretty much anything in its path, and by climbing into the canopy of trees or other plants, it can shade them out, impairing their ability to undergo photosynthesis. Over time, Chinese wisteria will climb and wrap around native plants, eventually shading them out and even girdling them.
This study from 2018 examines the effects of invasive species on local flora by measuring genetic diversity. Figure 5 shows that as the presence of invasive species increased, the genetic diversity of the native flora decreased. In Figure 6, overall genetic diversity was measured. As the presence of invasive species increased, the overall genetic diversity was also increased. This data supports the notion that native species are driven out by invasive species because the overall increase in genetic diversity observed in Figure 6 is due to the diverse population of many invasive species and not because of an increase in diversity among native flora. Wisteria sinensis has a relative which is native to the southeastern United States, Wisteria frutescens. Wisteria frutescens is still a vining plant that needs regular pruning to be controlled. However, the native wisteria is less aggressive than its Asian counterpart. The blooms are not as plentiful on the native species, which means they do not have the same ability to shade out other, smaller plants, but this characteristic makes native wisteria less desirable than Chinese wisteria in landscaping. Therefore, the best alternative to Chinese wisteria may be to choose another plant entirely that does not have the same harmful effects on neighboring plants. Planting a native alternative to Chinese wisteria will help control the spread of the invasive species, thus limiting the negative health impacts on the other local flora.